All right, Pythagorean theorem. We talked about this earlier with the United States map and trying to figure out the missing sides of a triangle. Pythagoras found that a right triangle is right, that then the sides will always follow a rule called the Pythagorean theorem. So the two legs squared will always equal the hypotenuse squared. So that's what we're going to talk about. So C is always the hypotenuse. So when you're looking at your triangle, it's that diagonal line. It's across from 90 degrees. So it's just always something just to keep in mind. Legs, when I talk about that, are the sides that make up that right angle. And they'll always be right next to each other. Let's just look at a few examples and see whether or not they are right triangles. So here I've got 2, 5, and 6. And what I need to do is I need to plug those values in to A, B, C. If you order your sides from least to greatest, you'll have, the first two numbers will be A and B, and then C is always the longest. So let's try this. We've got 2 squared plus 5 squared equals 6 squared. So we're going to square all the numbers. We've got 4 plus 25 equals 36. Well, at this point, we should be able to say that 29 does not equal 36, so it's not a right triangle. Right, and I made a right angle and then a triangle, just say right angle. Next, we're going to look at 10, 24, and 26. We do 10 squared, 24 squared, and equals 26 squared. Okay, well, 10 squared we know is 100. 24 squared, let me just do a little quick math on the side. That is 576. And 26 squared is 26 times 26. So that will get us 676. And if we add the 100 and 576, then we know it checks out. So the first example was a no, but the second one is a yes. All right, so we need to figure out the missing sides. So that is just using Pythagorean theorem. And with that, we want to make sure that we're remembering which side is going to be A, which one's going to be B, and which one's going to be C. So in the first one, we're trying to solve for C. So we should use the formula C equals the square root of A squared plus B squared. And then in number 2, because we want to find B, we're going to be subtracting this time. So inside the square it's going to be C squared minus A squared. What I need you guys to do for me is to figure out what these two answers are going to be, and we'll talk about it next time. Our next formula is going to be distance formula. So the first thing we have to remind ourselves is how to graph an ordered pair. So we always have it in xy. So our x is going to be 2, and then we go up 5. Then we've got 6, 5, so then we go over 6, and then up 5. So when we have a straight line going right to left, we just have to count in between. So that's just going to be 4 units. In example 2, instead of having a horizontal line, we're going to have a vertical line. And with that, you're still just counting, but you're going up and down. So we look for the difference, and we have that 5. So when we're trying to figure out what that slanted line is going to be, we can use what's called the Pythagorean theorem, so that A squared plus B squared equals C squared. Or we use distance formula, which we'll look at in a minute. So 2, 3 is our first. Negative 4, 6. Okay. And what we're trying to figure out is what the distance is of that slanted line. So the way to use Pythagorean theorem is we need to figure out how many units we're going down, which is 3, and how many units we go over. So we're really looking for the difference of the y's and the difference of the x's. From there, your a and b come from 6 and 3. So we're going to put in 3 plus 6 squared equals c squared. So we're going to square both those numbers, add them together, and then you've got c squared equals 45. So to undo that squared, you take the square root, and c equals the square root of 45, or 3 square roots of 5. And you should know, based on the buddy system, how I figured that out. Alright, 2 bells in one day. So distance formula is the same thing. We're really just plugging in all of our variables. I will go over this particular formula with you so that way you have a better idea. But your x's just come from the 2 and negative 4. Your y's are the 3 and the 6. So if we plug this in, you've got negative 4 minus 2 squared plus 6 minus 3 squared. So inside, you'll end up having the same exact numbers, and I'm just subtracting inside, showing you that the numbers inside are the exact same as in slide number 6. So we'll talk more about what this means and how to figure that out when I see you next.